about phase change calculations and how to determine how much heat is being released or absorbed during a phase change. Now, do you remember, or maybe this is the first time you're hearing this, but key concept, temperature is not changing during phase changes. Temperature stays constant throughout a phase change. Temperature is not changing. So that's a really important concept that's going to help you with the rest of this unit. So when you're calculating phase changes, you're going to use one of these two formulas. Now these formulas are found in your reference tables. They're on the page right behind the very first, so where all the formulas are. Now they actually have, instead of a delta here, they just have capital H, and instead of fusion, they just have an F. Okay? But it's the same formula. M stands for mass, Q stands for energy in joules, and this is a constant that will either be given to you or you'll need to go to your reference table to find it for water. So go ahead and look at your reference tables and find where it says heat of fusion of water on the very first page, where they list a whole bunch of constants. You have the heat of fusion of water, and for water it is 334 joules per gram. We use this formula, and we use that 334 joules per gram anytime we are melting or freezing a substance. So fusion refers to melting or freezing. Now I want you to think about this, because this is something that a lot of students miss. A lot of students miss this. I want to make sure you don't. When you melt something, do you have to add heat to the system, or do you have to take heat away when we melt something? So think about ice turning into liquid. Do we have to heat it up? Yeah, that means we add heat. Whereas when we freeze something, do we have to add heat, or do we put it in the freezer to take heat away? Definitely taking away heat. So the important thing here is you're going to need to determine what the sign is. If you have melting, you're going to use a positive number here, and it's going to give us a positive answer. If you're freezing, you're going to use a negative number, and it's going to give us a negative answer. And remember, delta H positive, that is endothermic, whereas delta H negative is exothermic. So you need to make sure that you know that as well. Okay, let's talk about delta H, the heat of vaporization. Vaporization is a word for boiling. So this is for the phase change of boiling or condensing. When we boil water, maybe to cook up some pasta, do we add heat to the water? Yes, therefore this is a positive number, and condensing is a negative number. So you need to make sure that you're looking at the phase change, figuring out what the charge is going to be, and putting that charge in properly. Okay? This formula is also in your reference table, so you don't have to memorize it, you just need to know it's there, and you need to know how to use it. So if you go to your reference table, you can see exactly what the value is, and it is 2260 for water. If you ever have a substance that's not water, I'll give you that constant. Usually we're dealing with water. So do you see this is the amount of energy required to freeze 1 gram, or as I should say, required to melt 1 gram of a substance of water. It takes 2,260 joules to boil 1 gram of water. So which one's more difficult to happen? Which one requires more energy? Definitely boiling. This is the one that requires a lot more energy. It's a lot more difficult to actually get a gram of water to boil than to melt. Think about it too. Doesn't it sometimes feel like it takes water forever to start boiling? That's because of specific heat, which is coming. But it also takes water a long time to actually boil to completion. That is because the heat of vaporization is much higher than the heat of fusion. Okay. So let me show you some example problems. Calculate the heat required to melt. Okay, we see the word melt, and I want you to take note of that word. So I'm going to circle it. To melt 25.7 grams. So I'm going to take note of this. First of all, here's our mass of water at its melting point. Okay, so when it says melt, we have to think back to our formulas. Which one do we use? We're going to use heat of fusion. So that's going to be delta H of fusion. Now, we've got to also think about the sign. Melting tells us that it should be positive because you have to add heat to get something to melt. Our final answer should be a positive answer. Look at this keyword, required. The problems are going to give you keywords to help you know the sign of the final answer. Required also refers to positive. You have to add heat. It requires heat. I need more in order for me to do this. In order for me to melt or whatever, the substance to melt, we need to add heat. So this is going to give us a positive answer. We're going to have to use the delta H of fusion, and there's our mass, and we're looking at water here. So Q, our formula, Q equals mass times delta H of fusion, okay? Now, mass is 25.7, okay? And then delta H of fusion for water is 334 joules per gram. We have decided that that needs to be a positive number because we're melting the substance. So, when you multiply those, grab your calculators and go ahead and put that in. 25.7 times 334. And when you do that, you should get 8,583. You need a unit. The unit for heat is joules. And if you look, the grams divided by grams, those cancel, so you end up with joules. Now, academic folks, there's your answer. Beautiful. There it is. Honors. I do need to talk to you about sig figs. Do not lose sig figs because of a constant. We've been doing that since the beginning of the semester. Don't lose sig figs because of a constant. There are 3 sig figs in your math. There should be 3 sig figs in your final answer. That is 8580 joules. Here's the honors answer right here. Academic, here's your answer. Okay? So, there you go. Let's do another problem. How much heat is evolved when 275 grams of water vapor condenses to a liquid at its boiling point? Okay. We're looking at condensation right here, so I'm going to circle that. That's telling us what we need to do. Condensation is delta H of vaporization. But we got to think about the sign. Is the temperature, temperature staying constant. Does it require heat or is it releasing heat? Does it lower its heat? In order to get something to condense, it has to cool down. That's losing heat. So it's going to be a negative number. And look at this word. Evolved means to kind of change, create, form, that kind of thing. It's producing it. And when you produce, you release. So that also tells us it's a negative. Right here is our mass. Okay? Now think, is this an exothermic or an endothermic process? We're releasing heat. Delta H is negative. This is exothermic. My students really have a tendency to struggle with exothermic and endothermic with phase changes. You got to think about what is actually happening. Do we have to add heat to get this to happen? That's endothermic. Do we have to remove heat, cool it down? That needs to be exothermic. Okay? So we're going to use delta H of vaporization. And our formula is to multiply that by mass. That's going to give us Q. We've seen that our final answer needs to be negative because its heat is ultimately being released here. So let's just do some plugging and chugging. Once you figure out what formula you use, the math really is pretty simple. 275 grams, there's the mass, times, we are looking at water vapor, so that's that constant here from our reference tables. 2260, that's the delta H vaporization, joules per gram. And all we have to do is multiply, whoop whoop, not so bad, the grams cancel, we do end up with joules. Heat is going to be joules. If you ever have to find this is joules per gram. This unit is in your reference table, it tells you. Ultimately, Q is joules, don't forget that. So 275 times 2,260, put that in your calculators, and you get a pretty big number. You get a pretty big number. 621,500 joules Now, I'm going to tell you a few things about this number before we move on. First of all, can you see here why maybe chemists prefer to be in kilojoules? Yeah, when you're in kilojoules, you'd lose you'd move over 3 decimal places. So it'd be 621.5 kilojoules. That's a much smaller number to deal with. You can definitely convert to kilojoules anytime you want for your final answers. Not necessary at all by any means. But I do want to talk about significant figures. Okay, just to be clear, this is our academic answer. In academic, if you have more or less digits, it doesn't matter. I don't grade you on sig figs. You probably don't even know what I'm talking about, which is okay. But honors, you'll always get a point for having the correct number of digits. So you need to make sure honors has to put this. Academic, you can put this, you could put this. Doesn't matter. I'm assuming that most of you would probably end up writing this one. But here we've got 1, 2, 3, 4 honors, folks. That's not going to be the correct answer for you, but this is a good academic answer. Let's talk about significant figures for honors. We don't lose or gain sig figs because of the constant. Just ignore it, because we could always look up another sig fig if we wanted to. But our mass has 3 sig figs. Final answer here should have 3 sig figs. 622,000, because that 5 causes that 1 to round up. So there is our honors answer. What I want you to be very careful with on these problems is figuring out your initial formula. If it's melting or freezing, we use this. If it's boiling or condensing, we use this. If it is not changing phase, but only changing temperature, we're actually going to use a completely different formula that I'm going to show you on the next video. Thank you so much for watching my video about phase changes.